Hi Professor, in this video we are going to show you the problem from the homework 2, the part number 2, and in this video we use different methods and we are going to explain how to solve it. So now we're going to start with my partner.
If we want to calculate the radius of the Earth, we just need to put a stick below the Sun in a vertical position, just like this. This is the stick, and the Sun will create a shadow of the stick on the ground. And now we just need to measure the height of this stick and the length of the shadow in order to calculate the alpha angle in regards with these two. So, in order to calculate this, we use the trigonometrical function tangent. So the tangent of alpha is equal to the opposite leg by the adjacent leg. And as we know, we only need to calculate this. So we convert this function into this. The alpha angle is equal to the inverse tangent of the opposite leg by the adjacent leg. So once we got this angle, the alpha angle, we know about rules that this angle is equal to this one because they are perpendicular to each other. So the theta alpha is equal to the alpha angle. And now we need to consider too this B angle right here, which is the representation of the declination of the sun in respect to the earth, in regards with the earth. So we need to consider these two. This the equator. This equator line represents the middle of the earth, and it's actually the radius we want to calculate. So this angle right here is by official data, taking in consideration that this was calculated on November. The declination of the sun is equal to minus 20 degrees. So we need to add this angle to this one. So once we add these two angles, we also need to know the distance between the position of where we measure the stick and the equator. So this distance needs to be calculated. And now, once we know the distance, and we also add the theta alpha angle to the declination of the sun, which is 20 degrees angle, we need to consider that this one is the distance between our position and the equator, and this is the angle, the current angle we need to calculate. Now, considering that the Earth is a circle and it possesses a 360-degree, we just need to apply a rule of three. So we calculate the Earth perimeter with that rule. So this the d, which is the distance from the equator to our location, it's multiplied by the division of the complete degree circle of the Earth, which is 360 degrees, by the addition of the theta angle plus the declination of the sun. So this calculation right here, it's the perimeter of the Earth, and we will name it P. So once we got the value of P, we know that the formula for the perimeter is 2 by P by radius. So now that we need to calculate this one, we convert this formula into this one. So the radius is equal to the P or perimeter by 2 by P. So, sorry, radius is actually equals to p by 2 times p. So this formula right here is the one that we use to calculate the radius of the Earth. If we want to calculate the radius of the Sun, we need 2 sheets of paper and the current official distance between the Earth and the Sun, which is 149,597,870.7 kilometers. So the first step is to make a little hole in the middle of one sheet of paper and put it below the Sun. So we take the other sheet of paper and we put it below the first one. And now we let the light of the Sun pass through the hole of the sheet of paper and made a little reflection in the bottom one. And so we can measure the distance between the 2 sheets of paper as the height. And then we measure the diameter of the little hole reflection. We will name the diameter of the little hole as D and the height of the distance between the 2 sheets of paper as H. So we apply the Thales theorem in this case, using a triangle to represent one side as the diameter of the Sun. So this theorem says that if we extend one side and the other one of the triangle, we can create another one that is proportional to the first one. So if we take this side as the diameter of the Sun and this one as the diameter of the little hole reflection, and we take in consideration the height between the 2 sheets of paper, this height, and the distance between the Sun and the Earth, we can make a conversion with this. So D, it's the diameter of the Sun. This D, it's the diameter of the little hole in the sheets of paper, and this H is the height between the 2 sheets of paper. So with applying a rule of 3, we use this distance between the Earth and the Sun, and we multiply it to this distance, to this diameter, and we divide it by this height. So we apply the formula here and we obtain the capital D, that is the diameter of the Sun. So now that we calculated the diameter of the Sun, the final step is to divide it by 2, and then we got the radius. In order to calculate the distance between the Earth and the Sun, we need to consider this. This calculation is based on the waning quarter, which is the moment when the Moon is slighted at half by the Sun. This creates a rectangular triangle among the position of the Moon, the Earth, and the Sun. We also need to consider that the distance between the Moon and the Earth by official data is 384,400 kilometers. We also need to consider these two angles. The one in regards with the Earth is 89.85,277,516 rays. And this one in regards with the Moon is 90 degrees over a rectangular angle. So now that we know that the position among these three is a rectangular triangle, we can assume that the distance between the Earth and the Sun could be the hypotenuse. So in order to calculate the hypotenuse, we know that we can use the trigonometrical functions. So which one do we need to use? Well, now that we know this information, the better option is the cosine trigonometrical function, which is the cosine of the angle equals to the adjacent leg by the hypotenuse. So if we convert this to calculate the hypotenuse, we got this. The hypotenuse is equals to the adjacent leg by the cosine of the angle. And now we just need to proceed to the calculation. So the adjacent leg is 384,400 by the cosine of the angle 89.85,277,516. The result of this calculation is 149,597,866 kilometers. So this is technically the distance between the Sun and the Earth, or the hypotenuse in this case. But if we want to convert this into meters, we just need to multiply it by 1000. So we got this. Is 149,597,866,000 meters. So this is the official distance between the Earth and the Moon and the Sun.
Hello, my name is Jesus Guillermo Viles Granados, and today I'll be explaining a way to find the measure of the thickness of a paper sheet, the thickness of a bubble of soap, and the atom's diameter. For this one, it will be just an explanation. For these two, will be an exercise. So let's start. So for the first topic, what we have to do is to find a way to measure the thickness of a paper sheet. And for that, it exists various ways to do it. The first one, more simple, is with the help of a tool named micrometer that is used to measure the thickness of paper sheets or pieces of cloth and etc. The second way would be to take a bunch of paper sheets, all of them of the equal thickness, and measure the thickness of all of them together, then divide that measurement between the numbers of paper sheet that we have in the bunch. And for the last one, and this one is when we only have one paper sheet, what do we have to do is we have this one. What do we have to do is to fold that paper sheet so we can apply the same method that we did in the last way. So start by folding it very well. Right here, then right here. Make sure to fold it very well, because there is layers of oxygen that can make an error in the measurement, and it won't give us the right measurement for this. And now what do we do is I will be using a ruler of 10 centimeters And what we have to do is to press the paper so we can have a right measurement, and it's 4 millimeter, no, sorry, 3 millimeters. And what are we going to do is to, sorry, it was not in there, it was in here, I'm sorry, but it's the same, it's 5 millimeters. What are we going to do is to divide 1, because we only have one piece of paper sheet, between that 0.5 centimeters, and that would be all for the first topic, that is to find the way of to measure the thickness of a paper sheet. And let's pass with another one. And now for the second topic, what we are going to do is to find a way to measure the thickness of a soap bubble. And for that, we have the next exercise that says, calculate the minimum thickness of a soap bubble film, and it gives us mu, which is equal to 1.68, and that result in constructive interference in the reflected light if the film is illuminated with light whose wavelength is free space in lambda equal to 800 nanometers. And what are we going to do is to use the next formula, that is 2 mu multiplied by t, that in this time will be the thickness, equal to n minus 1 medium multiplied by lambda, where now we have mu and we have lambda, but what is n? Well, n could be any natural number from 1 to the infinitive. So we are going to use for this exercise the number 1. So we replace the n by 1 and we rewrite it right here. Lambda, mu multiplied by t is equal to 1 minus 1 medium lambda. And what we have to do right now is to clear the formula so we can have the thickness of the bubble of soap, and it will be like this right now. Our thickness will be equal to 1 medium multiplied by lambda to mu, and that will be equal to lambda for mu. And now we replace the values that we have in here and we put them in this part of the formula. and it will be first lambda, that is 800 nanometers, but this time what we are going to use in meters, so it will be equal to 800 multiplied by 10 to the minus 9 meters, and this will be divided by 4 mu, that in this time is 1.68, and that will be equal to 119.04 multiplied by 10 to the 9 meters, and this will be the result. But if we want it in nanometers, it will be equal to 119.04 nanometers. It can be represented in this way for meters and in this way for nanometers. And that will be all for the second topic, and let's pass for the third and last one. And now for the third topic, that is to find a way to measure the atom's diameter. We have the next exercise that says find the diameter of the aluminum given its density and mass for 1 mole. That is right here. Aluminum's density is equal to 2.7 grams between centimeters cubic, and the mass for 1 mole, that is equal to 27 grams. This 1 mole is 1 mole of aluminum, obviously. And what are we going to do first is to change all units in terms of kilograms and meters. And we start with the density of aluminum, that is 2.7 grams between cubic centimeters. This one will be equal to 2.7 per 10 to the minus 3 kilograms per meters. And for the mass, it will be 27 grams equal to 0.027 kilograms. And now we are going to use the next formula, that will be density multiplied by the Avogadro's number. And all of these will be divided between the mass. And now let's change this for the values that we have in here, and this will be equal to 2.7 per 10 to the minus 3 multiplied by Avogadro's number, that is 6.02 per 10 to the 23rd, and all of these will be divided by the mass that is 0.027 kilograms. Okay, so what do we have to do now? It's to make the cube root of the formula, and this one will be equal to 6.02 per 10 to the 28, and we'll find the cube root of this one, that is equal to 6.02 per 10 to 25. We'll do the cube root here, and this cube root will be equal to 3.9 per 10 to the 9th. And now we are going to divide 1, because we just have 1 mole of the aluminum, between this result, and it's going to be 1 between 3.9 per 10 to the 9, and it will be equal to 2.55 per 10 to the minus 10. And this one will be the diameter of the aluminum, and it will be all from me in this video. Thank you so much for watching it, and bye.